Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's video, a 3D printer for glass, marine robots that monitor the oceans, and a 3D printer that uses 10 materials. Though 3D printing, yes, there's a bit of a theme in this week's Engineering Update, has rapidly moved towards an affordable price point, and many 3D printers are capable of printing using different materials, the technology still has a bit of a ways to go when it comes to printers that have the ability to 3D print more than one material at once. Even some of the most advanced machines struggle to print 2 or 3 materials, which makes the fact that MIT was able to create a printer capable of printing up to 10 materials at the same time even more impressive. The team was able to create the 3D printer for less than $250,000, which is what a traditional 3D printer capable of printing just 3 printers will run you. The researchers, who work at MIT's Computer Science and Artificial Intelligence Laboratory, used 3D scanning techniques from machine vision. The advantages to this technique are twofold. First, this 3D printer is capable of self-calibrating and correcting using 3D scans to detect errors and then correct them. The second advantage is that the multi-fab system means that you can embed complex components like circuits, so you're not adding things after it's finished printing. The team has test printed traditional objects like phone cases, but also more technical parts like light-emitting diode lenses. They're planning on tackling even more complicated items like medical imaging and microsensing. The team was able to build the machine from off-the-shelf components totaling around $7,000.
Aquabots, also known as marine robots, are the most advanced way to measure the reaches of the oceans, rivers, and lakes, and are helping scientists learn more about our global waterways. A principal research fellow at the Institute for Future Environments at the Queensland University of Technology has added inference to the already large mix of underwater robots. The robotic boat system, designed to be fully autonomous and live on waterways for months at a time, was built from fiberglass. The various sensors on the robots give researchers real-time environmental information on everything from water quality to gas emissions. The solar-powered robots use differential steering and GPS to move around the ocean. They have a camera on board to help them avoid the shoreline and are designed to run on minimal power. The robots are also made to carry different things, such as a camera, greenhouse gas sensors, or a machine that collects physical water samples. It can even launch a remotely operated underwater vehicle. The robots are able to investigate highly polluted sites like mines, and they're even testing underwater volcanoes with this new robot. At a price point of less than $3,000 each, the robots are intended to fill a gap in our knowledge about water systems.
When you think 3D printing, you typically think plastic. While there are some sophisticated 3D printers out there that produce more than just plastic, the typical 3D printer is usually limited to its material options. But a new breakthrough in 3D printing could vastly expand the technology's applications. MIT recently unveiled a method that allows the creation of complex 3D glass structures to be printed in a similar way to plastic parts. The machine, called G3DP, uses the foundations of 3D printing and applies them to the same process used in ancient art glass production. The machine uses 2 chambers, one that acts as a kiln cartridge that heats up to 1900 degrees Fahrenheit, and another that works to melt the structures together. The molten glass is distributed through an alumina zircon silica nozzle that pours out, sort of like soft serve ice cream, or cake frosting, if you will. I'm so hungry today. The MIT team says the goal of this machine is not just to create beautiful glass sculptures, though this would be pretty cool for 3D printing hobbyists out there. The precision of the machine means 3D glass printing could lead to new advances, like creating fiber optic cables that transmit data more efficiently, or an architectural design optimized for solar power. Just watching this machine work is pretty entertaining, and if anything, it'll get you thinking about ice cream or other deliciously gooey food that comes out of a nozzle. That's all for this week's Engineering Update. Be sure to check in on Twitter and Facebook and watch past episodes at ecnmag.com. For the ECN channel, I'm Jamie Wisniewski, and this has been your Engineering Update. It's creepy. I know, I'm so hungry. Should I cut it? You can
My upper lip is sweating.